Algebra 2, 8.6, we're splitting up in two sections. Part of it goes right with what we've been doing here with our rational expressions. So, shouldn't say solving rational expressions. What it should read is solving rational equations. All right, it's all about examples. You know the ins and outs here. The difference is you now have x in fractions. First example we'll have is this. You've heard this before. We keep saying it. Equations that have fractions in them are more difficult than no fractions. So when we have fractions, it's a little more difficult, so get rid of the fractions. Or denominator, I should say. How do we get rid of the denominator? Just like we've been practicing on our last set of notes. Use the LCM, the least common multiple. So as you look at this problem, we see a 5, a 3, and a 9. So our LCM here will be 45. What we're doing, we're ridding ourselves of the denominator. So everything gets multiplied by this 45. Everything. Some people do it this way, some people put it on each side. You'll see me do it both ways through our examples. Multiplied by 45, multiplied by 45, and the common mistake is people forget that other side. So, what happens as we do these? Well, as we do our work, we've got 45 over 1 times 4x over 5, 45 over 1 times 2/3 equals 1/9 times 45 over 1. What's all this going to yield? Glad you asked. We can cross reduce. 5 becomes 1. Isn't that 9 times? 9 times that gives us 36x. Here, 3 goes into 45, so it becomes a 1. That becomes a 15 plus 30 on the other side of the equal sign. 9 goes into 45 5 times equals 5. All right, next step. Notice, no more fractions. Solve for x. So x is equal to negative 25/36. Okay, now in our next example here, we've got a little more complicated. Our denominators now have algebraic expressions in them. So rule of thumb here is step 1. Factor the denominators. Step 2. Use your LCM to get rid of fractions. Okay, so we're going to factor. Here, nothing to factor. 2 factors of 15 that add up. So that's going to give us x plus 3, x plus 8. I factored that, so I'm going to draw a line through it. And x plus 3. So we look at x plus 5, 8, 5, sorry. Got an x plus 5, repeat, x plus 3, repeat. So what's our LCM going to be? X plus 3 times the quantity of x plus 5. So as I survey this whole problem, will this denominator have to change? If that's what we want, the answer is no. So all we got to do is change this one and this one. So how are we going to go about doing that? Got to take that times there. I've got to take this fraction on the other side of the equal sign. And again, why don't I have to do this middle one? Well, alright, I guess I do technically because it's going to cancel it out. Let's not jump any steps here just because we're not in class. Guarantee that we're all following along here. Okay, so there, I'm going to show everyone my steps, not jumping anything. So as we look, here's what happens. Denominator, you can always do this, x plus 5, quantities cancel each other out. So we're left with this x plus 3 times 2x. So multiply, distribute. 2x squared plus 6x. Now, here's where I was jumping the gun. Since they're identical, I know those are going to cancel out. But this is a key ingredient. This whole quantity is being subtracted. I'm writing it out. Some of you might jump the gun and change all the signs, but that's a mistake that we got to avoid. Not changing all the signs. Here, our denominator, x plus 3's, x plus 3's, distribute 3x plus 15. Okay, we are now combining like terms, so distribute your negative here, here, and here. Negative x squared plus x plus 10. So as we combine our like terms, here, here, x squared, 6x and x plus 7x, and then plus 10, 3x plus 15. So we look, quadratic, not going to cancel out, put it in standard form. So x squared, subtract 3x from both sides, plus 4x, subtract 15 from both sides, minus 5. Okay. So as we go through this, we have to solve a quadratic. Now, factoring patterns, this is where you could use quadratic formula, you can complete the square if you really wanted to. Two factors of negative 5 that add up to be positive 5, negative 1. So x plus 5, x minus 1 equals 0. Two answers. X is equal to negative 5, x is equal to positive 1. So now, what do? Check to see. Go back to your original, to your denominator. All the way, yeah, you can see it. Right here. Will that negative 5 produce anything for us? The answer is no. So the only solution, this would be extraneous. The only solution to this problem is going to be positive 1.